Hi, we're going to find the distance from a point to a plane. The point is x0, y sub 0, z sub 0, and the plane is ax plus by plus c plus d equals 0. The first step is we're going to drop a perpendicular line from p sub 0 to the xy plane. We're going to drop a perpendicular line to the xy plane and going to the given plane. And let me call this point P1. It is a right angle as well. So since we are going straight down to the xy plane, the x coordinate and the y coordinate doesn't change. And we need to find the c coordinate. Well, we have ax plus by plus cz plus d equals 0. We're going to plug in x equals to x sub 0 and y equals to y sub 0. And we're going to solve for c. All right. So we had a times x sub 0, b times y sub 0, plus d equals to minus c times z. And c equals to a times x sub 0 plus b times y sub 0 plus d and dy by minus c. And that is the c coordinate. Ax 0, by 0, plus d dy by minus c. All right. And now take a look at these two equations here. We have ax plus by plus cz plus d equals 0, and ax plus by plus cz equals 0. These two are parallel planes. If you try to solve the system, if d is not equal to 0, then you will have a contradiction. That means you cannot find an intersection point between these two equations. So they are parallel. They are parallel planes. But the second equation goes to the origin. And let me show it to you. The second equation is just a plane going to the origin. And that is the equation. It is ax plus by plus cz equals 0. All right. But this one can be written as a vector equation. I have the vector ABC dot the vector xyz equals 0. So it is the position vector xyz on the plane, and there is the vector ABC, and they are perpendicular because dark part equals 0, so they are perpendicular. But these two planes are perpendicular. So I mean, these two planes are parallel, so this normal vector, let me call this the normal vector. And this normal vector should be perpendicular to the given plane. So that is the normal vector. Okay? It's perpendicular to the plane. All right. And now, how do we find out what is d? Well, d is just, look at this triangle here. If that is angle theta, this one will be angle theta. So D equals to the magnitude of the vector P1, P0 times cosine of theta. The hypotenuse times cosine theta gives me D. And now I'm going to multiply up and down. I'm going to multiply up and down by the magnitude of the normal vector. I can do that. Same quantity. So, but this is just the dot product of P1, P0 dot to the normal vector. Y by the magnitude. And what is the vector P1, P0? We just use the endpoint, subtract the initial point. So I have the endpoint is x0, y0 is c sub 0. So we have x0 minus x0, y0 minus y0, and z sub 0 minus this quantity. So I change to positive ax0 p y0 plus d, and divided by c. And they subtract that, become a positive sign here. And we're going to dot to n and divide by n, the magnitude of the normal vector. All right? So we're going to continue over here. We'll continue over here. So what do we get? D equals to 0, 0. Simplify this. We have a times x sub 0 plus b times y sub 0 plus c times z sub 0 plus d dy by c times, we're going to dot to the normal vector, which is what? The normal vector is a, b, c, so it is just a, b, and c, and divide by the magnitude. The magnitude of the normal vector would be just square root of the sum of the squares of the components. So it would be a squared plus b squared plus c squared. So 0 times a is 0, 0 times b is 0, and this quantity times c. So the c cancel out. So this cancel out, the c cancel out. So we just have a times x sub 0 plus b times y sub 0 plus c times c sub 0 plus d, and everything divided by square root a squared plus b squared plus c squared, and take the magnitude because we want the distance to be positive. And I guess that's the end of it. All right, and that is the formula. And thank you for watching.